Hello everyone. I am Saim Safdar and a co-host for the nice session on TLS for Kubernetes cert-manager. I am a community manager at Cloud Native Islamabad, and this is a webinar session on managing secure communication with Kubernetes with our speaker Brendon. He is a DevOps platform engineer at Technology Resource Group, and I'm really excited to have in our webinar. And tonight we're learning everything that's related to the cert manager and Kubernetes. And I hope the people who are joining this session know a little bit about the Kubernetes and the security aspect as a whole. I know this topic as a cert manager and security is not a passionate interest to everyone, but it is a topic of interest to cloud native engineers, cloud native security engineers, and Kubernetes engineers as well. So right now we can do anything great in our laptop with our manager, but the Kubernetes give us a default solution for that. I'm really interested to learn something great from Brendon. So head it over to Brendon. At the end, I ask you a few questions and few alternative. So right now you can go through what it is and why we want to use this. Over to you, Brendon.
All right, thank you. So as Sam mentioned, my name is Brendon, and I'm really excited to have this opportunity to share with you. I've been a DevOps platform engineer for about 18 months, and I've always been infatuated with automation, and I am constantly trying to hack things together to find better ways of delivering value to my customers. And so with our focus on TLS tonight, we should start with what TLS is. And so TLS stands for Transport Layer Security. And so anytime you're using HTTPS to communicate, that's that secure HTTP, and it's going to use TLS. In the past, there was also SSL. You may hear people still refer to TLS as SSL, but in the strictest of sense, SSL has been deprecated, it's retired, it shouldn't be used anymore. And TLS, like its predecessor, uses PKI, that's Public Key Infrastructure, and it's basically a lot of mathematical formulas that allow us to have keys that are public that can decrypt information that we encrypt with a private key, and that can encrypt data that we can decrypt with the private key, but nothing in between. That's something, there's a lot of intricate, very involved stuff going on in that. If anyone is more interested in that, you should look at TLS handshakes and PKI, that infrastructure generally. And TLS, it's going to be based on a lot of short-lived certificates. That's to protect things. So if a certificate is lost, it gets exposed to the public, it shouldn't have a very long life so that it's not going to be able to be used in a malicious way. And there's actually more and more requirements around that. Another key concept of TLS is root certificate authorities. So a CA is a certificate authority, and any web browser, any operating system is going to have a lot of trusted root CAs that come with it. And those are the building blocks on which every single publicly valid certificate in the world is based on, either directly or indirectly through what are called intermediate certs. And so we're actually going to be using custom certificate authorities when we get into the demo portion here. And we're going to have to do some stuff a little bit special in order to make sure that we can trust those, because they're not part of this elite few of trusted CAs. And one last thing to mention is, so a TLS certificate, using that public key infrastructure, it's going to have to be associated with a domain name. And so we can either create certificates for a single domain name. That's actually what we're going to be doing in the demo here. But if that is not going to suit your particular needs, you can also look into concepts around a wildcard certificate. That's where everything is good for a certain domain and all of its subdomains. So for example, if you had a wildcard certificate for star.example.com, that would be good for dev.example.com and www.example.com and any other subdomain. Or you can use what's called a subject alternative name, or a SAN. You also may hear that referred to as a DNS name, and that's going to allow you to give several domain names for a single cert. So it's actually considered maybe a little more safe than a wildcard cert, because that wildcard cert has much more exposure if it does get if it becomes publicly available, so people can do more with it. But these are just some concepts to keep in mind if you want to do more research. So that's a little bit about what TLS is, but why should you care? Obviously, we want to encrypt data that is sensitive. So if we have a web form where a user is entering in, a social security number, they're entering in a driver's license or a birth date, any of these national identifiers or unique identifiers that are sensitive to an individual's privacy, we want to encrypt that so it can't be intercepted. So we're protecting that in transit. And then when it comes to things like credit cards, there's PCI compliance where you have to have a certain type of certificate and a certain level of encryption in order to be legally allowed to accept that data, depending on what jurisdiction you're in. Another thing, so that's kind of protecting data that's coming in to, from the client to the server, but there's also protection of data going back to the client. So for example, if you have a website that loads JavaScript, it has a URL in there to grab some JavaScript from some URL. If that URL is not protected, if it's just using HTTP as an example, it's very easy for a hacker, for some bad actor to basically man in the middle that so that they're getting your request and giving the response back, and they can give some malicious JavaScript there. Very, very easy to do that. And so that's why you probably should go ahead and encrypt all your traffic, whether you think you're using sensitive data or not. There's also the customer confidence. I'm sure people using modern web browsers will notice if you go to a site that is not secure, either you're getting the green check mark that it is secure, or some browsers are actually changing to more the mode of, instead of giving a green check mark if you are using HTTPS, it's giving a big red warning sign if it's not. And the last thing you want to do, especially if you're trying to get your image out there for your company, for whatever it is, you want the people who are coming there to have confidence in your website. And anything you can do to avoid this big red flag that's going to make people a little nervous is going to be good. Now, within Kubernetes, it's very common to hear discussion about what's called north-south traffic, which is what I've been talking about. So that's coming from, if you think of your traditional client-to-server communication, that's north-south. But then there's also east-west, where in particular, if you have microservices, you're going to have a lot of communication there. And I want to just call this out because what I'm going to focus on in the demo is not going to be anything to do with the east-west traffic. If you want to look more into that, and if in particular, if you want to have automation around that and simplicity, you should really look at some of these service mesh offerings or a sidecar like Envoy. And then the last big selling point for TLS is if you want to use some of the latest technology, you have to have TLS. So for example, HTTP2, if you want to use that in order to make your sites more performant in a lot of scenarios, you have to have TLS. So those are some reasons why you would want to do it. And so TLS in Kubernetes, the easiest way, or at least perhaps the most straightforward way, is through adding TLS to an ingress. So, as you might know, you would have a deployment, or a pod. You would associate that with a service, and then you can have an ingress expose that service to the outside world. And to put TLS associated with that ingress, it's very simple. We just need to add to our ingress in the spec section. We need a TLS stanza that has hosts and a secret name. And in that secret name is going to be in the same namespace as our ingress is. That secret is just going to have a data entry named TLS.cert and TLS.key. And those are going to represent the actual certificate that is going to be used to communicate over the domain name that's provided. So both of the examples that we're going to do here in a little bit are going to come back to this idea of creating a secret and exposing it through an ingress. So with that, let's look at what it would take to create a TLS certificate and use that through manual management. So I'm going to jump over to VS Code, and we're just going to talk through a script. And all of these, I have these on my GitHub account. So my GitHub name is just Brendon Thiede, and I'll share that with Saim so that you can have that. But here for our demo, all we're going to do is create a folder, and in that folder we're going to create a certificate authority. So earlier we talked about there are these trusted...
Brendan, can you please increase the font size?
Sure.
Sorry.
Yeah, let me try to enhance the font here. Oops. There's that a little better for you?
Yes, that's the look perfect.
Once I move some of this stuff around. There we go. Can you read that all right?
Yes.
Okay, great. So yeah, first thing we need is a certificate authority. Technically speaking, you can create a self-signed cert, so that's a certificate that does not have a certificate authority. However, that if you want to trust that certificate, you have to manually trust that certificate for your operating system. And so if you have many certificates, you would have to trust each one of those. To make that easier, I highly recommend, even for a development scenario, a test environment, internal only, where it's not the general public hitting it, I would still recommend creating a certificate authority. So here I'm using Open SSL. So that's a very common tool in Linux. You can also, get it on Windows through WSL2, however you would like. But what we're going to do is create a private key, use that private key to create a certificate, and then we're going to create a TLS key pair, which is going to be that TLS.cert and that TLS.key that are going to end up in our Kubernetes secret. So I'm going to go ahead and copy all this down to there. And here, let me see if I can get this to increase my font as well. Oh. Actually, I'm not so sure. I don't want to really mess around with that right now. I'm not sure I can increase the font here as I wanted. Let me see if PowerShell would let me. Oops. That was not what I wanted. Here we go. Sorry about that. Okay. So I am using multipass. So that gives me my Ubuntu VM where I'm running K8s. So we're going to connect in there. And now I can run all my stuff. So it ran fairly quickly there. And so we have a CA cert, a CA key, TLS cert, TLS key. And just for the sake of this demo, and kind of generally speaking, a key is something you absolutely want to protect and you don't want to share it with anybody. A cert is going to be public. And these are, there are many different formats you can have certs in. These are PEM formatted, so it's just a base 64 encoded content. So we can actually cat that out. And you'll actually even see that in the cert, it says begin certificate, end certificate. But when we look at the key, it says it's a private key. So it says begin RSA private key. And when it says private, keep it private. So that gives us our certs. And then now we're going to create a secret from that. And this is just a suggestion that I have is I try to never directly use kubectl create. So here I'm using the create command because it has extra options, which makes it very easy. So I can say create secret TLS, so that gives it the right secret type. And then I also can just give it cert and key as parameters. But I'm taking that as a dry run, so I can pass that to a kubectl apply, because I like to keep everything declarative to make it easier to update later on. And if we look back, I'll actually try to scroll through the code here to see where it was. Right here. No, not right there. Here. So the CA is valid for 5 years, but then here we are, 6 months for the cert. So you will need to update certificates. So even if you're doing them manually, it's good to keep them with a shorter expiration. I think, I want to say it's 380 days, I think. I can't remember for sure. It's actually in a write-up that I did recently. There's a maximum longevity of certs, a maximum expiration time in the future. And if you go beyond that, browsers are actually starting to not trust those. And in particular, if you use the latest Mac operating system, it'll stop you from going to sites with a cert that's valid too far in the future. That's just considered too much of a hazard. So anyway, that's why we want to be able to update these things easily. Now, in order to use that cert, so right now we've got our secret. We can see it's of type kubernetes.io/TLS. We can actually look at it and see that there's going to be some sections in here for the TLS cert and the TLS key. So that's what's in there. So now let's actually use that. So we're just going to create a simple deployment. This deployment is just using an nginx pod and exposing that. as I mentioned before, we're not trying to encrypt the east-west traffic. So this pod, the service is using port 80. So what that means is that the Ingress controller, so in K3s it uses traffic, or nginx is a very popular Ingress controller. The Ingress controller is serving up this TLS certificate, and then it's terminating that TLS and using a standard, just port 80 HTTP request from the Ingress controller to the service. So that's just something to keep in mind. For my current role that I'm in, for my current client, we actually have to encrypt all the traffic. That's one of our requirements. So we have to even have certs at this level. But that gives us our service. So we've got our pod. Actually, let's just double check everything's working well. Let's do get all. So we've got our pod here, manual secure web. We've got our service, manual secure web, listening on port 80. And now we're going to take the code for the Ingress, which is the last bit of this. Oops. There we go. And so now we have our Ingress. And we see that it's listening for manual.secureexample.com, and it's using address 172.17.253.60. Now this host name, it has to match the DNS name that we created the TLS certificate for, or else we'll get warnings. But we're going to get some warnings anyway. So let's see what this looks like. So first off, because I need to use this host name, the way I'm going to do that is I'm going to edit my etc host file. So you can see I've already done some entries in here, and actually the IP address is the same. So I'm on Windows, and I'm using VS Code. So you can see the path here, the C:/Windows System32 drivers etc hosts. You need administrative privileges to edit this file. So it's actually, VS Code is smart enough to be able to ask me to do that. So I say yes, retry as admin. I tell it I trust it to do it, and it's going to do that. And so what this is doing is it's going to make sure that my DNS gets bypassed with this entry for this particular host. So I can come over to my browser now. So let's come here. We'll go to HTTPS. And we get a warning here. And you'll notice that the message here says cert authority invalid. Well, we can actually, without even going any further, we can actually see why. So I'm in Edge, which is based on Chromium, so it's going to be very similar to Chrome. Most browsers, you're going to have some sort of a lock icon here or something, and you can come and you can check out the certificate. So I click here, and it says the certificate is not valid. And if I look at the certification path, it's not showing me anything here. If you were to look at another website, you might see a chain that goes all the way down to a root, one of those trusted root certificates. But here, we don't get all that. So instead, on the general, we can see it's issued to manual.secureexample.com, which is the URL we're using, issued by OpenSSL CA. So that's the CA that we created. So that's why it's not trusted. But we can just click the advanced, and we can actually continue anyway. And we do that, and we see that we've got the generic, nginx pod or nginx container image giving us a response here. So that's how we do it the manual way. Now, there's a lot going on there, right? We had to manually create the TLS cert and the TLS key. And furthermore, we would have to do that for every Ingress every domain that we want to expose. Now, if you've got the same domain for everything, you can use the same cert, but if you have many subdomains for different applications, you would need to create those, and you would need to make sure you're maintaining them so they don't expire, things like that. So that's where cert-manager comes in. And so cert-manager, you install that into your cluster, and then you can create either an issuer or a cluster issuer. And the only difference there, as you might assume from the name, a cluster issuer can issue certificates for any ingress in your cluster, whereas an issuer can only do it for a specific namespace. And the huge benefit of cert-manager is that auto-renewal. And it's going to add a lot of custom resources. I shouldn't say a lot, but you're going to get some custom resources around certificates, which can make it a little easier to understand what's going on versus only having those certificates, with that Kubernetes IO/TLS type. And in the end, it's just going to be annotation driven. And so for the simplest examples, all you need to do is in the metadata of your ingress, you just tell it what issuer, or if it was a cluster issue, what cluster issuer you're going to use. And that's it. All the magic will happen from there. So you put this annotation in your ingress, and then you have a similar annotation as what we did before, where in the spec you're telling it that TLS information, and that secret name, you still provided a secret name just like we did in the past. So if we jump back a couple slides here, this secret name would still be there, but instead of us creating it ourselves, cert-manager is going to go ahead and create that. Now, certain issuers, there are many. Certain issuers do require additional information here. So for example, I currently use Vault to provision certs for my clusters. And so with the policy that Vault has for my, I have to have a Vault role and secret that can connect to Vault to be able to provision those certificates. It is a requirement of it that it has a common name. So I actually have to, in my annotations, provide a common name. If I wanted to have subject alternative names, I would also provide those in annotations. So that's just something you can look into. It's going to be specific to the issuer that you have. If you have a cluster that is publicly addressable, so it can be reached from just any old person, a very good candidate for very easily setting up TLS for you would be to use the ACME, ACME, the ACME issuer. That's, if you're familiar with Let's Encrypt, it's that same thing. So it's going to automatically use a certificate authority that is trusted by pretty much any browser in the world. But the reason I say that that's good for a public, a publicly facing cluster is in order for you to get the certificate, it's going to want to do some validation. And so the typical way that for me at least, the way that I usually do it is you will ask for the cert and it will say, okay, I will give you a cert for this domain name, but you need to prove that you own that domain. And the way you're going to do that is by putting this certain file at a certain path so that I can come back, hit that path, find the value, that I've agreed that you would give me, and then that'll be my proof that you own that domain. Obviously, if you're behind a firewall, it's an internal only site, that might not work for you. So in our case, what we're going to do is we're going to use the CA issuer. And so the CA issuer is probably the second easiest issuer to use. And so we're going to use, just like we did in the last example, we're going to create a CA, but instead of using that CA to create a certificate, we're going to, a TLS certificate, we're going to use that CA to create an issuer. So now we're going to do this for the cert-manager example. So here we go. So a lot of this is going to be the same. So this here, we're creating a CA again. And actually, I can use the same one I already had. That'll work just fine. So I'm actually going to jump right here, and I'm going to create that secret. In here, you'll notice rather than using the kube control create and then piping that to a kube control apply, I'm doing it explicitly. But that's because I wanted to, or I needed to rename things, because most if not all, I'm not sure if all do, but most of these certificate or most of these secrets that you use for TLS, they expect a name of TLS.cert and TLS.key. So even though here it's a certificate authority, it still expects that same name. So this was an easy way for me to do that. So anyway, I'm going to jump back over here. Oops, actually, we were here. We're going to do that. And because we already had our cert and our key, from the last time, we're good to go. So we created our cert, and now, actually, oh, here, I knew I skipped something. I was like, that isn't right. So we actually need to install cert-manager. So that would be a good thing for us to do. We're going to come over here, and I'm just doing it from their GitHub repo. You can see it did, several things. The key thing that we need to do right now is just wait for the pods to come up so we can create an issuer. So everything is going to be in the cert-manager namespace, and we see that they're all ready and running. So we are good to go. So we've got our CA injector and the webhook for the cert-manager, because that webhook is how the issuers actually interface with it. So now here we can create our issuer. So we're telling it that we want it to be a CA issuer because of the spec here that says CA, and we're giving it a secret name. So this is that secret that we just created. We're going to copy this. Okay, we now have an issuer, so we can, and this issuer is only in our default namespace. That's where I set it up. Doesn't say it's ready yet. I think it might in a little bit here. But similar to before, we're going to create a deployment. It's just another nginx pod. So I'm going to go ahead and create that. And then this time, instead of just having the TLS and secret name in the spec, we've also got that annotation, where we're telling it the issuer that we want to use is CA issuer. So let me copy that. Let me check on that issuer again. Oops. Okay, now it's ready. So you can go ahead and paste this in. All right. And so this time we wanted CM, so I prefixed everything with CM for cert-manager. So we did not manually create the secret, but we should see it now. Oops. And I did the wrong thing there. And there, I'm making it worse. Oops. Yeah. So CMTLS. You can see it was there, created 28 seconds ago. that is the secret for that particular ingress, and it was created by cert-manager. And I already, if you noticed from before, when I set up my host file, I also put in this CM secure. And so we're going to come out here, just like before. And if we look at the certificate, we see the same CA, but it's a different issued to. And if we choose to click through, we'll get some trust there. And I actually, because I don't want to close the browser, we can be clever about this though. I actually want to show how you can trust this cert. So let's imagine a scenario where you've decided you want to use TLS. You want to use it for your development environment. You don't want to pay for one of the big name certs, a Symantec or a Thought or any of GoDaddy. You don't want to pay for a cert, so you want to use just a CA that's only internally trusted, like what I just did. But you don't want to have to click through these security warnings every time. So what you can do is something like this. So we've got our CA cert. So it's just the cert. What I can do, I can cat that CA cert here. I'm going to just copy this. And I am going to just here, because I like to use VI. Actually, yeah. Well, you might not be able to see very well is the only problem here, but should be fine. If I'm just going to paste in what I had. So I'm just making it so I have that cert on my Windows machine now. Now if I come here, I've got my ca.cert. What I can do is I can look at that, and so this is for Windows. It's going to be a little bit different for Mac, a little bit different for Linux. But in the end, what you want to do is trust that certificate for your machine. So I'm going to say install. I'm going to do it for current user, and I'm going to have to tell it where to place that certificate, and that's going to be in the trusted root certificate authorities. So that's that list of, it's around 240, I think, something like that. I'm just telling it, add this one in as a custom cert. So I'm going to do all that. It's saying this thing looks really sketchy. Are you sure? I'm going to say, yeah, just trust it. And so now I don't want to close Edge because we've got the meat going on. But what I can do, I'll copy this URL, and now I'll go to Chrome. Because you have to close, in particular with Edge. It might not be true of all browsers, but I've noticed you have to close it and open it again to get this certificate to get picked up. So here we go. You'll notice I did not get the security warning. So I can look here. I can look at the certificate. It's the same issuer and issued by. It's the same certificate. But now it gives me a certification path of this cert for cm.secureexample.com came from this trusted root of OpenSSL CA. So, and furthermore, I can show you that I happen to already have this open. So this is on Windows. Actually, it looks like I have to close it in order to get it back there again. On Windows, I can look at my user certificates, and here I can look at my trusted root authorities certificates, and then we'll look for OpenSSL, and there it is, OpenSSL CA. And so if you decide you need to remove this, replace this, you can actually just go ahead and delete it right here. and then things would go back to the way they were before. And just for completeness, the previous cert we generated used the same certificate authority, and so because we trust that certificate authority, well, now I look like a liar. That should have been trusted. I'm actually not sure why that didn't. I might have done something to the cert and messed it up. But anyway, so that ends the examples that I had. So at this point, I guess, are there any questions?
Thanks, Brendon. It's a really exciting session. A lot of school stuff going, ton of great stuff, Cloud Manager. First question, do everything need changes in Kubernetes 1.20 related to Cert Manager?
Cert Manager itself, I don't believe has any changes between, like I'm using Kubernetes 1.19 in my examples. Cert Manager itself, I don't believe changes, but ingresses do. Right, so the way that you specify the TLS stanza for an ingress controller is going to change a little bit.
Yes, and when the initial question coming up, that's first I'm not using the Cert Manager. So there I'm using the Open SSL. So I do all these stuff from me, so certify, giving a trusted root authority, other stuff manually. I don't have a renewal process. So Cert Manager is actually giving me more the stuff that I'm using that. So the Cert Manager is a things that we can use locally to test the certification process, or it's going to be used in the production, or why want to use it in production, in which scenario is going to be better, or in which cases it's not going to be used anyway.
Right. So here's kind of my reasoning for why I would recommend something like Cert Manager. So even if you're manually, using OpenSSL in, a lower environment, your non-production environment, Cert Manager is, for one, it's going to automatically do the renewals and such, because you're typically a certificate authority might be valid for 5 years, for 10 years, something like that. Whereas a lot of certificates, like I was saying, the maximum life that browsers will trust them is, not very long. It's like just over a year or something like that. But by using, Cert Manager, not only are you not having to do that manual monitoring and updating of those certificates, but you're also potentially creating it so that you can use the same paradigm in production as in your lower environment. So in production, if you had one of these issuers that uses a trusted certificate authority from somewhere else, be it through Acme, or if you have like Vault that uses a valid intermediate cert, you can basically have it look very much the same. All you need to change is the issuer. As long as that issuer has the same name in your development cluster, all your pre-production clusters and your production cluster, then you wouldn't have to change anything for your resource definitions for your ingresses.
Okay, thanks. That's a really. But one other question is that if you are using the north-south traffic, and we have the east-west traffic.
Yep.
So is going to be any scenario in which I use Cert Manager and proxies like service meshes, Istio and Linkerd at the same time, or it's going to be an overwhelm for use to manage doing these things separately.
Yeah, and it depends on what type of. So if you're using a service mesh, it may depend on what type of service mesh you're using. If you're using a service mesh that also has, like an API gateway functionality, it may actually supersede the need for Cert Manager. because in the end, if it's something that can provide a certificate that's valid for your ingress, that's the only thing we care about here. And depending on your infrastructure, you might not even care about how valid that certificate is for your ingress. If, for example, you have a load balancer in front of your ingress, so that all your real cert, if you will, your GoDaddy or your few hundred dollar certificate that's publicly valid is at like an A10 or an F5 or something like that. It may just be that certificate gets offloaded and it communicates over a different certificate to your ingress. So it's kind of that standard answer of it depends, but it really does depend a lot on what your infrastructure looks like and where the certificates need to be valid. Because the last thing you want to do is have an end user out on the internet who's trying to get to your service. You don't want to have to tell them, oh yeah, it works great, just click through these security warnings and tell it that you want to trust things that it's suggesting you shouldn't. And I know
Okay,
a bit
another
long-winded,
one
but
question, that if something like I am not comfortable in managing the cert manager, is there a yes? So it's a question for the people who don't want to manage cert manager for themselves. They want to manage things so they can do all the stuff on behalf of him, and he's just watching it relax. Somebody else is doing their job. Is there a things in Kubernetes for managing certification by itself or of the whole?
So I think what you're talking about is kind of the different workflows depending on the different types of issuers. And so if you go to the cert-manager website, they have a handful of issuers listed there. Let's actually go there real quick. So cert-manager issuers. So here's the one. Nope, that's not it. Issuer. Actually, this is not the list that I wanted. Please give me the list that I wanted. Yeah, the amount of effort that different people in different roles would have to do are going to depend on the type of issuer that you're using. I know I have a link on here. So this is the blog post that I created to kind of prepare myself for this. So most of what we've talked about is in here. Here we go. Issuers. There we go. So depending on the type of issuer, it's going to change where a lot of the management of things goes. So for example, I mentioned I use the Vault issuer. So what I need to do is so for me, when I create a new cluster, so kind of that one-time operation for a cluster, I'm going to give it the Vault credentials for a role that is allowed to get the certificates. And then, I help the application teams to have, in their Helm charts, in their Kubernetes resources, to have those annotations. I tell them the pattern for that, which is, again, typically just a one-time thing. But as far as what domains you're allowed to create certificates for and all that, that's managed by our security team who manages our Vault instance. So if they need to change anything with the PKI policies, so for example, if there's a new subdomain added that we want to be able to generate certs for, we would need our security team to update that policy. But once they do, everything should be automatic from the cluster's perspective. And when if one of our development teams creates a new ingress rule that references this new domain that the policy is now available for, it'll automatically just pick that up and be good. So the kind of the simple answer would be, depending on your needs, you might look at the different certificate issuer options to see if there's one that matches your particular needs.
So thanks, Brendon. I saw you wrote an article there. We put a link up here in the YouTube. You can guys and read about this. And if you wanted to get along with this webinar, so they can try it out on your own. Really interested session and learn a ton of cool stuff from you. And hope we can find you in a future webinars as well, because TLS certification managers have ever evolving technologies, and is going to be things moving rapidly and in this space. And you have a very, very passionate in this field. So I really learned a ton of cool stuff. So let's kind of wrap things up. So where does people find you on the internet? So if they want learn or ask some question after the session, or Twitter or whatever you will call.
Yeah. So my website is digestibledevops.com. That's where I put a lot of presentations that I do. I put everything here. And all of that is through GitHub. So if you go to GitHub, Brendon Thede is my handle there. And you can find my entire website is open source there. All the examples that I do are going to be available there. And then on Twitter, I'm ThedeBR. And yeah, that's about the only place I ever go anymore. So,
okay, thanks. Really, really appreciate it. I put the links to if you want to follow the Brendon Thede on Twitter, ask question. You can ask question here in YouTube. We'd love to point out more. And we hope to see in future webinars on Brendon Thede in action as well. Really appreciate. I learned tons of cool stuff from you, and really appreciated your time. You're very late here in United States of 11:35 p.m. And I am doing session in the morning, so it's going to be very, very good fun. Really enjoy your session. So stay healthy, everyone, and stay safe. And we hope to see you in our future webcast here in future webinar in Cloud Native Islamabad YouTube channel. So thanks you guys for joining, and thank you very much, Brendon Thede, for having in our webinar. Thanks, everybody.
This was a lot of fun. Thank you.